welcome back. So today we are going to solve all the questions from definite integration which came in different shifts of Jan 2025 attempt. In definite integration we have total 13 questions, out of which 8 are easily doable, 4 are moderate and 1 is easy but lengthy, which we are going to solve. And this difficulty level is basis my perception, which may be different for others. So let's move on to our first question. Here is our first question now. Our question says, let f of x is equal to this integral where x belongs to R, then the number of local maximum and local minimum points of f respectively are. So here we need to find the number of local maximum and local minimum points of f. So to find that, first of all we will take derivative of f of x. So this will be f dash x is equal to, we will put x square in the place of t, we will get x raised to power 4 minus 8x square plus 15 divided by e raised to power x raised to power 2 into derivative of x square will be 2x is equal to 0. So our e raised to power x raised to power 2 is always positive and 2 is also always positive. So we can take it to the right hand side. It will not affect the sign of f dash x. So this will be x square minus 5. We can write this quadratic as x square minus 5 into x square minus 3 is equal to 0. Now further this will be x into x plus root 5 into x minus root 5 into x plus root 3 and x minus root 3 is equal to 0. Now let's plot this in the wavy curve. We will get minus root 5 minus root 3 0 root 3 root 5. Whenever x will be greater than root 5, this is always positive. When it's between root 3 and root 5, it will be negative. And when it's between 0 and root 3, it will again be positive. And when it is between minus root 3 to 0, it will be negative. When it's between minus root 5 to minus root 3, again it will be positive. And when it's less than minus root 5, it will be negative. So from here our number of local minimum points is equal to, we will get local minimum when our sign goes from negative to positive, because then our graph of f of x will go from down to upwards. So this point will be local minima, and at this point our derivative is also 0. So the points where sign changed negative to positive are 1, 2 and 3. So number of local minimum is equal to 3 and number of local maximum is equal to, we get a local maximum when our sign goes from positive to negative. So here we have points of local maximum 1 and 2. So our number of local maximum is equal to 2. From here, our answer is 2 and 3, because the question says number of local maximum and local minimum. So 2 and 3. And here is our solution page, and we can see that our answer matches correctly. Here is our next question now. Our question says the value of this whole integral is. So here we need to find the value of this integral. So one direct substitution which I can see is ln of x. Ln x is equal to t. Then we will get 1 upon x dx is equal to dt. From here, this will be integral from, let's say our this integral is I. Our I is equal to integral from 2 to 4 e raised to power t square plus 1 minus 1. 1 upon x dx will be dt, and divided by this will be e raised to power t square plus 1 e raised to power minus 1 plus e raised to power 6 minus t square plus 1 raised to power minus 1 dt. Now here we are going to use in rule. So we will get our I is equal to integral from 2 to 4. We will replace t by 6 minus t. So we will get e raised to power 6 minus t whole square plus 1 raised to power minus 1 divided by e raised to power e raised to power t square plus 1 whole raised to power minus 1. Sorry, this will be e 6 minus e whole square plus 1 raised to power minus 1 plus this will be e raised to power t square plus 1 whole raised to power minus 1 dt. Let's say this is our first equation and this is our second equation. Then we will add our both 1 and 2 equations. We will get 2 times I is equal to e raised to power t square plus 1 raised to power minus 1 plus this expression, and the same expression we will have in the denominator. So both numerator and denominator will get cancelled out, and we will be left by integral from 2 to 4 dt, 1 dt or dt. So this is equal to 4 minus 2. From here our I is equal to 1, and so from here our answer is option C. And here is the solution, and we can see that our answer is correct. Here is our next question now. Our question says if I is equal to this, here we have made some corrections. I is equal to this integral, then integral from 0 to 2 times I is of this integral equals to what? So first of all we need to find our I, then we will put it in the upper limit, then we can solve this integral. So our I, let's say this is I1. So I1 is equal to integral from 0 to pi by 2 sine 3 upon 2x divided by sine 3 by 2x plus cos 3 by 2x dx. Now here again we are going to use using King's rule. So from here our I1 is equal to integral from 0 to pi by 2 cos of 3 by 2x sine of pi by 2 minus x will be cos of 3 by 2x divided by cos of 3 by 2 x plus sine of 3 by 2x dx. Now let's say this is our equation 1, this is equation 2. We will add equation 1 and equation 2. We will get 2 times I1. 2 times I1 is equal to sin x raised to power 3 by 2 plus cos x raised to power 3 by 2, and we have same denominator and the same numerator. So from here both numerator and denominator will get cancelled out. So this is equal to integral from 0 to pi by 2 dx. From here our I1 is equal to pi by 4. Now let's say this is our I2. So I2 is equal to integral from 0 to 2 times I is pi by 2 of x sine x cos x divided by sine 4x plus cos 4x. Now again we are going to use using King's rule. So dx. So we will get our I2 is equal to integral from 0 to pi by 2. X will be pi by 2 minus x into cos x into sine x divided by cos 4x plus sine x raised to power 4 dx. Now let's say this is our equation 3rd, this is equation 4th. So equation 3 plus equation 4 will be 2 times I2 is equal to x plus, because the overall expression is same, x and pi by 2 minus x is changed. So x plus pi by 2 minus x will be pi by 2 integral from 0 to pi by 2 sin x cos x upon sin 4x cos 4x. Here we are going to divide both numerator and denominator by cos 4x. So we will take 2 to the right hand side. 2 is equal to pi by 4 integral from 0 to pi by 2. 1 in the numerator we will get sin x upon cos x, which is tan x, and cos x upon cos of cube x will be 1 upon cos square x, which is sec square x. This is plus, divided by, when we will divide denominator by cos 4x, we will get tan x raised to power 4 plus 1 dx. Now here we are going to substitute tan square x is equal to t. So from here we will get 2 tan x sec square x dx is equal to dt. Now we will put these substitutions. So I2 is equal to, we will get 2 in the denominator, so we will take it outside the integral. Pi by 8 integral from 0 to when we will put tan square x, then we will get infinity in the upper limit, and dt upon t square plus 1. So from here this is equal to pi by 8. This integral is tan inverse t from 0 to infinity. So this is equal to pi by 8 into pi by 2, which is equal to pi square by 16. So our answer is option C. And here is our solution, and we can see that our answer matches correctly. Here is our next question now. This is a very easy question. If I of m comma n is equal to this integral where m comma n is greater than 0, and I of 9 comma 14 plus I 10 comma 13 is. So first of all, we need to find the addition of these two integrals in term of another integral. So let's write it. I of 9 comma 14 plus I of 10 comma 13 is equal to integral from 0 to 1 x raised to power 8 1 minus x raised to power 13 dx plus integral from 0 to 1 x raised to power 9 1 minus x raised to power 12 dx. Now in this integral we will take x raised to power 8 and 1 minus x raised to power 12 common. Inside we will get 1 minus x plus x dx. So here x and x will get cancelled. So we will get this as our integral, which is equal to, according to the above, I of 8 plus 1 9 comma 12 plus 1 13. So our answer is option D. And here is our answer, and we can see that our answer matches correctly. Here is our next question now. Our question says, let for some function y is equal to f of x. This is our equation given, and f of 2 is equal to 3. Then f of 6 is equal to. Now using this equation we can find f of x, and with some arbitrary constant we can remove the constant from this equation. Then we can easily find the value of f of 6. So we will take derivative both sides of this equation. We will get x f of x is equal to 2x f of x plus x square f dash x. Here our x, x and x will get cancelled. So from here we can say x into f dash x is equal to minus of f of x. We can write this as dy by y is equal to minus of dx by x. Now we will take integral both sides. We will get ln y is equal to ln integral of minus 1 upon x is ln of 1 upon x, or integral of dx upon x will be ln x. We will take minus 1 inside, so this will be 1 upon x, plus we can write constant c as ln of c. From here our y is equal to c by x. Now when we will take our x is equal to 2, then our y is equal to 3. So from here c is equal to 6, y is equal to 6 upon x. So our f of 6 is equal to 1. From here our option A is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, let f be a real valued continuous function defined on positive real axis such that g of x is this integral. If g of x cube is this, then we have to find the value of this sum. So using this g of x and this equation, we will find f of x. Then we will find the value of this sum. So first of all, we can write g of x from g of x cube. Our g of x is equal to x square plus x raised to power 7 upon 3. Now let's check it. We will put x cube is in the place of x. This will be x raised to power 6 plus x raised to power 7. Yes. Now, in this equation, we will take derivative both sides. We will get g dash x is equal to x f of x. Our f of x is equal to g dash x by x, and this is equal to derivative of g of x, 2x, x will get cancelled, 2 plus 7 by 3, x raised to power 4 by 3 minus 1, so it will be x raised to power 1 by 3. From here we can say f of r cube is equal to 2 plus 7 by 3 r. Now our sigma r is equal to 1 to 15 f of r cube is equal to sigma r is equal to 1 to 15, 2 plus 7 by 3 r. This is equal to 2 times 15, 30 plus 7 by 3 into 15 into 16 divided by 2. So 3 will cancel 15 5 times, 2 will cancel 16 8 times. So this is equal to 280 plus 30, 40 into 7, 280 plus 30 is equal to 310. From here, our option D is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, let f from r to r be a twice differentiable function such that f of 2 is equal to 1, capital F of x is equal to x into small f of x for all x belongs to r, and here we have two integrals. Then we have to find the value of this expression is equal to. So first of all, we are going to use these two integrals and the given relations to find these two values. Then we will add it up, or we can get in between of the equations. So let's try. First integral from 0 to 2, 0 to 2x capital F dash x dx is equal to 6. This will be x. We will take integral of f dash x and derivative of x. So in the first, we don't need to take derivative of x. So f dash x will be f of x from 0 to 2 minus integral from 0 to 2 derivative of x and f of x dx is equal to 6. Now from here, our integral from 0 to 2 capital F of x dx is equal to 2 times capital F of 2 minus 6. Now we can write capital F of 2 as 2 times f of 2, and we know the value of f of 2 is equal to 1. So this will be 4 minus 6 is equal to, from here, integral from 0 to 2 f of x dx is equal to minus 2. Now we have another integral from 0 to 2 x square f dash dash x dx is equal to 40. Now again we are going to use integration by parts in this integral. We will get x square capital F dash x and plus integral from 0 to 2 times, when it's from 0 to 2 times because derivative of x square is 2 times x, so it will be 2 times x into capital of f dash x dx is equal to 6. Now this integral is equal to 6 as given here. So from this we will get 4 times f dash 2. This is equal to 40. And we will take this is minus. We are using integration by parts. 40 plus 12 is equal to 52. So from here our f dash 2 is equal to 13. So from here f dash 2 plus integral from 0 to 2 capital F of x dx is equal to 13 minus 2, 11. So our answer is option A. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says the integral of 80 times this expression is equal to. So we need to find the integral of this expression. To find that, the first substitution I think is sine theta minus cos theta is equal to t. From here we will get cos theta plus sine theta d theta is equal to dt. Now this is our integral, so let's say this is I. Our I is equal to 80 times integral from 0 to 0 will be minus 1 and pi by 4 will be 0. Sin theta plus cos theta into d theta will be dt divided by 9 plus 16 into sin 2 theta will be 1 minus t square, because this will sin 2 theta is of 1 minus t square. 1 minus t square. So from here we will take 16 common from the denominator. 80 upon 16 integral from minus 1 to 0 dt. We can write 25 upon 16 as 5 upon 4 whole square minus t square. So this is equal to 80 upon 16 is 5 divided by 2 times a. 2 times 5 by 4 into ln mod of 5 by 4 plus t divided by 5 by 4 minus t. From minus 1 to 0. From here this is equal to, this expression will be 2, and here when we will put 0, ln will also be 0. So inside we will get minus of ln 1 by 4 divided by 9 by 4. So this is equal to 2 ln 3, sorry, 2 ln 9. So this is equal to 9 is 3 square, so this will be 4 ln 3 ln 9. So from here our option B is correct, and here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says if this integral is equal to this expression where alpha comma beta belongs to z, then alpha plus beta whole square equals. So using this relation we will find alpha and beta, then we can find alpha plus beta whole square. Now let's say our I is equal to integral from minus pi by 2 to pi by 2 96x square cos square x divided by 1 plus e raised to power x dx. Now here again we are going to be using King's rule. So we will get I is equal to integral from minus pi by 2 to pi by 2 96x square cos square x divided by 1 plus e raised to power minus x. We can write it as 1 plus e raised to power x and e raised to power x in the numerator dx. Now let's say this is equation 1, this is equation 2. Equation 1 plus equation 2 will be 2i is equal to 96 into 2, 96 into 2, because when we will add it, 1 plus e raised to power x will get cancelled. We will get 96x square cos square x. So inside we will get even. So we can change minus a to a as 2 times integral from 0 to a x square cos square x dx. Now this is not a, this is pi by 2. 2 and 2 will get cancelled, and our cos square x will be 1 plus cos 2x divided by 2. Yes. Now this is our I is equal to 48 integral from 0 to pi by 2. 1 upon 2 will cancel 96 as 48. Integral from 0 to pi by 2 x square dx plus 48 integral from 0 to pi by 2 x square cos 2x. Now here we will make two columns of differentiation and integration. This is a shortcut to solve these types of integration by parts problem. We will take derivative of x square until it gets 0, and we will take integral of cos 2x. Number of times we have taken the derivative of x square. So this will be cos 2x minus sin 2x divided by 2 minus cos 2x divided by 4 minus sin 2x divided by 8 plus minus plus minus. Now we will multiply the x square with 1 down. So x square with minus sin 2x by 2 minus 2x with minus cos 2x by 4 and so on. So our I is equal to, this is x cube by 3, so pi cube by 8 into 3. So pi cube by 24, 48 upon 24 will be 2 pi cube. This is pi by 2 plus 48 into, inside we will get x square minus x square. This is positive side. Sin 2x by 2 into x square plus 2x cos 2x by 4 minus minus will get cancelled, minus 2 times sin 2x by 8 from 0 to pi by 2. So this is equal to 2 pi cube plus 48 into, inside when we will put pi by 2, this term will be left, 2 times pi by 2 cos pi divided by 4 minus pi by 4. So this is equal to 2 pi cube minus 12 pi. We will take pi common, 2 pi square minus 12. Alpha is equal to 2, beta is equal to minus 12. Alpha plus beta whole square is equal to 10 square minus 10 square 100. So from here our option D is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, let f from 0 to infinity to r be a twice differentiable function if for some a not equal to 0, we have this equation where f of 1 is equal to 1 and f of 16 is equal to 1 upon 8. Then we have to find this, the value of this expression is equal to. Now using these three equations, we need to find the value of given expression. So in the first equation, we will put lambda x is equal to u. We will get integral from 0 to x, 0 to x, f, so on. We will get x d lambda is equal to du. We will get f of u. F of u du is equal to we will take x to the right hand side because in this integral x is a constant. So it will be a x f of x. We will take derivative both sides. We will get f of x is equal to a f of x plus x f dash x. We will get x f dash x or x x f dash x is equal to 1 minus a upon a f of x. So from here dy by y is equal to 1 minus a upon a integral of dx by x. We will get ln y is equal to 1 minus a upon a ln x plus c. So our x is equal to 1, y is equal to 1. According to this, x is equal to 1, y is equal to 1. Please wait a minute. So let's come on here again. X is equal to 1, y is equal to 1. So from here we will get c is equal to 0. Now our x is equal to 16, y is equal to 1 upon 8. We will get ln of minus 8 minus of ln x is equal to 1 minus a upon a ln 16. We will get 16 raised to power 1 minus a upon a is equal to 2 raised to power minus 3. 2 raised to power 4 minus 4 a upon a is equal to 2 raised to power minus 3. 4 minus 4a is equal to minus 3a. We will get a is equal to 4. Now from here our y is equal to x raised to power minus 3 by 4. From here our f dash 1 upon 16 is equal to minus 3 by 4, 1 upon 16 raised to power minus 7 by 4. So this is equal to minus 3 into 1 upon 16 is 2 raised to power minus 4. Minus 4 into minus 7 by 4 will be 2 raised to power 7. 4 is 2 square, so 2 raised to power 7 minus 2. 2 raised to power 5. 32 into 3 is equal to minus 96. From here 16 minus f dash 1 upon 16 is equal to 16 plus 96 is equal to 112. From here our answer is equal to 112. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says let f of x is equal to this integral. X is between 1 to 5. The range of f is alpha to beta, then 4 times alpha plus beta equals 2. To find, here we need to find range. So first of all, we will take derivative of f of x. We will get f dash x is equal to x square minus 9x plus 20 is equal to 0. x minus 5 x minus 4 is equal to 0. Now let's plot this in the wavy curve. 0 0 4 5 plus minus. Now our graph is from 1 to 5. So let's say this is our extended version of graph. So at 0 we are getting the point of minima, but our minimum point of the function in the domain is 1. So this point is 1 comma f of 1. This point is 4 comma f of 4. And this point is 5 comma f of 5. Now first of all, let's write f of x, then we will check all the values, then we can easily find the range. Our f of x is equal to x raised to power 4 upon 4 minus 3x cubed and plus 10x square. So from here our f of 1 is equal to 1 by 4 minus 3 plus 10, 1 by 4 plus 7, which is equal to 29 by 4. Now our f of 4 is equal to 4 raised to power 4 upon 4, so 4 cube, it will be 64 minus 3 times 64 plus 160. This is equal to 160 minus 64 times 2, so 128 equal to 32. Now our f of 5 is equal to, we can write this as 5 times 125 upon 4 minus 3 times 125 plus 250. So this is equal to minus 7 by 4, 125 into minus 7 upon 4 plus 250. So this is equal to 1000 minus 5 3 3 4 3 7 1 8 75 divided by 4. So this is equal to, this is 1000. So this will be 125 divided by 4. So our range is equal to Now here our minimum is 29 upon 4, comma. Now 4 times 32 is 128. So this is between 29 upon 4 and 32. So beta will be 32. Alpha is 29 by 4. Beta is 32. We will get 4 times alpha plus beta is equal to 128 plus 29, 157. So from here our option D is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, if this integral is equal to 2 pi plus alpha, where this denotes the greatest integer function, then alpha is equal to. So here we need to solve the integral, then we need to find the value of alpha. So first of all, let's deal with the mod of 4x minus pi by 12. Now, for this we have two possibilities. 4x minus pi by 12 if x is greater than or equal to pi by 48, and pi by 12 minus 4x if x is less than pi by 48. Yes, pi by 48. Now you can write our integral as 24 times integral from 0 to pi by 48. Now sine of pi by 12 minus 4x, we can write it as minus of sine 4x minus pi by 12 dx plus integral from pi by 48 to pi by 4 of sine 4x minus pi by 12 dx plus integral from 0 to pi by 6. We will divide it by pi by 6 for the change. 0 to pi by 6, 2 sin x dx plus integral from pi by 6 to pi by 4, 2 sin x dx. Now, here adjacent of 2 sin x will be 0. This will be 0. This will be 1. So from here, let's write the integral 24 times. This will be cos of 4x minus pi by 12 divided by 4 from 0 to pi by 48 minus cos of 4x minus pi by 12 divided by 4 from pi by 48 to pi by 4 plus this will be 0, and integral from pi by 6 to pi by 4 1 dx will be pi by 4 minus pi by 6. So from here we will get 24 times 1 upon 4. Inside we will get 1 minus cos of pi by 12 minus of now cos of pi minus pi by 12 we can write it as minus of cos pi by 12 and minus 1 plus this will be pi by 12. So from here these two terms will get cancelled out. 1 plus 1 2. So this will be equal to 2 pi plus 24 upon 2 12. So from here on comparing our alpha is equal to 12. So our answer is equal to 12. And here is our solution and we can see that our answer is correct. This is our next question now. Our questions is let f of x is equal to this whole expression. I1 is this integral, I2 is this integral, then 7I1 plus 12I2 is equal to. So first of all let's write f of x. From the first two terms we will take tan 6 tan raised to power 6 7 times tan 6x common. Inside we will get 1 plus tan square x. It is tan square x plus 1. I am writing it like this. And similarly from here 1 plus tan square x. Now when we will take 1 plus tan square x common, 1 plus tan square x is sec square x into we have 7 tan 6x minus 3 tan 2x. Now our I1 is equal to integral from 0 to pi by 4 7 tan 6x minus 3 tan 2x dx, sec square x dx. Now here we will put tan x is equal to t. We will get sec square x sec square x is equal to dt dx is equal to dt. From here this is equal to integral from 0 to 1 76 minus 3t square dt. This is equal to t7 minus t cube from 0 to 1 and this is equal to 0. So our I1 is equal to 0. Now in I2, our I2 is equal to integral from 0 to pi by 4x 7 tan 6x minus 3 tan 2x secant square x dx. Now we are going to use integration by parts. We will integrate this part and take derivative, and this will be the other part. Please wait a minute. Yes. Now this is equal to x. Integration of this part we can take it directly from this here. We will get 7 tan 6x, tan 7x minus 3 tan cube x from 0 to pi by 4. Now this will become 0 minus integral from 0 to pi by 4 of this expression tan 7x minus tan cube x. So we can write this expression as, we will take tan cube x common. Inside we will get tan x raised to power 4 minus 1. We can write it as tan square x plus 1 tan square x minus 1 dx. Now tan square x plus 1 is secant square x. Now this is equal to minus of, or here we will put tan x is equal to t secant x whole square is dx is equal to dt. We will get this is equal to minus integral from 0 to 1 t cube into t square minus 1 dt. So this is equal to minus of t raised to power 6 upon 6 minus t raised to power 4 upon 4 from 0 to 1, and this is equal to 1 upon 4 minus 1 upon 6. From here I2 is equal to 1 upon 12. So 7I1 plus 12I2 is equal to 1. From here our option B is correct, and here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.